and welcome to our lesson 3.1, our first lesson in a chapter about lines and angles. We're going to begin by defining some words. Some are familiar, some are new. Most of us have a definition, a working definition for parallel lines that says that they are lines that will never intersect. And for the most part that is true, but you do need to add one little qualifier with it. In order for lines to be parallel, they have to be in the same plane, or there has to be a plane that will contain them both. So parallel lines technically are coplanar lines that never intersect. And I'll show you what I mean by that here in just a second. I want to have you locate this segment DK. We're going to talk about it a little bit here. You can see that that's running back and forth, left to right. This line, FO, or that segment FO, you know, it's not running the same direction, right? It's not running left to right. However, so it's not parallel, but it also is never going to intersect. A pair of lines like that are not parallel but don't intersect are called skew lines. And the textbook definition for skew lines is this: they are non-coplanar. That is, there is no plane that can contain them both. And if you think about that, you'll realize it's true, because to contain this line and this, that plane would have to bend in the middle, and planes don't do that. So non-coplanar lines is the short definition, but it probably makes more sense to us to think they are not parallel, but they don't intersect either. Not parallel and don't intersect. Now, what I'd love to have you do is use that information. I want you to stop the video. We're going to do these two activities. All segments parallel to DK, all segments skew to that same segment DK. Alright, here are my results. You may have named, of course, the letters in opposite orders, but you should have come up with 3 segments parallel to DK. All 3 of those run exactly the same direction, left to right, FL, OW, and UC down here at the bottom. The segments that are skew to DK, well, we already had mentioned OF. There's this guy, WL, and then there are these two. CW, see, it's not on the same plane. Again, it can't be on the same plane with DK. It's on the bottom floor of this box, if you will, and it doesn't run the same direction. So CW and UO are also skew to that segment DK. Our next idea is parallel planes, and folks, planes cannot be skew. You only get 2 choices there. They either intersect or they don't, and so parallel planes will never intersect. So that would be something like the top and bottom of this rectangular prism, or side to side, etc. Of course, now the activity doesn't ask you to name parallel planes. It asks you to name all the planes that intersect with a given plane, and the plane that we're interested in is CKLW. That's this wall in this picture. Alright, let's stop that video. I want you to get those intersecting planes written here. I have 4 intersecting planes. I have the back wall, I have the top and bottom, and I have the side. Okay? Only one plane that's pictured that it does not intersect, and that's the parallel plane. Let's move on. Today we want to focus in on angles that occur when lines are crossed. And what we want to do is define a line such as line T here. It's called a transversal. That's why we use the T for it. A transversal is just a line that intersects 2 or more coplanar lines. They all have to be in the same plane. In this case, M and N are being cut by this transversal. In that diagram, you can see that the transversal line T forms 8 different angles with lines N and M. We want to define some angle types here, and the names are very descriptive. It won't take us long to get these things. These 8 angles have some special names, and the names are very descriptive about where they're at in the diagram. Same side interior angles. If you would think about that for a minute, interior, you can think of that as being between or on the inside, if you will. So same side interior angles are angles that are on the same side of the transversal. That is, they're either left of the T line or right of it, but they're between the two lines. So a pair of same side interior angles would be angle 4 and 5, and there's another pair that you should be able to name. Angles 3 and 6, same thing. They are on the same side of the transversal in between the two lines. The next of the styles of angles are similar. These are same side now exterior angles. And if this meant between, this means outside of them. So not on the inside anymore of the two lines, but on the outside. Same side of the cut through, outside the two lines. That would be angle pair like angles 1 and 8. And there should be another pair that you can find, I'm sure you have. Angles 2 and 7 fit that same criteria. Same side, but outside. The next of the angle types we want to talk about are corresponding angles, and I want to give you a pair of these before we reveal. A pair of corresponding angles is angle 1 and angle 5. And I'm going to just ask you to think about this for a minute. What they have in common is that they are both above their line and they are to the left of the transversal. So if I were talking about this pair, I'd say above and left. And now I want to reveal that definition. Corresponding angles are angles that are in the same position relative to the two lines and the transversal. That is, both of these angles are above their line and to the left of the transversal. You should be able to pick out 3 other pairs of corresponding angles by using the same thinking. I said above and left. Can you find the ones that are above and right? And you would say, certainly, Mrs. Brownfield, that would be angle 2 and angle 6. They are above their lines but to the right of the transversal. There are 2 more pairs. How about 4 and 8? How would you describe those? Under, right, below, and to the left. And the last pair of corresponding angles in this diagram, angles 3 and 7, and those would be below and to the right. So corresponding angles, same position relative to the two lines and to the transversal. Alternate interior angles are angles that are on opposite sides of the cut through, the transversal, but between the two lines. So you have to be in between the two lines and on opposite sides of the cut through. That would be something like angles 4 and 6. And the other pair of alternate interior angles, angles 3 and 5. Then lastly, alternate exterior angles, and you all know where this is going. Opposite sides of the cut through, but this time outside of the two lines, and that would be a pair like angles 1 and 7 or angles 2 and 8. Opposite sides of the cut through, outside the two lines. Very good. Now we named and described a series of angles. Now we'd like you to take a look at this picture. It may be hard to see in your notes, but it's asking for us to make a judgment about angle 1, which is right here, and angle 3, which is right here. So it might be a good idea to think, okay, here are the two lines that makes this the cut through. And angle 3 and angle 1, well, they're both above the cut through and to the left of their line. If they are doing the same thing relative to the lines in the transversal, that makes them corresponding angles. And that's where we leave it tonight. We've identified and described several different types of angle pairs. These are going to be important to us as we go through this chapter. Get out there and do that U-try, and we'll see you in school.